Now you have completed writing all the UVM classes, and your final UVM environment is looking like this picture. So it has a UVM environment with multiple sub agents in that and a scoreboard, and this environment is instantiated in the UVM test, and the test is starting UVM sequences into the sequences. So this is the final architectural representation of any UVM based testing component. So you will be instantiating your top level test class and the top level DUT design module into a module called the TestBench. So this is your top level TestBench module, which is a Systemverilog module, and within that module you need to instantiate your DUT like any other TestBench, and if it is a UVM TestBench, you need to instantiate or create an object of the top level class or top level test class which you want to run in this particular simulation or into the DUT. So this is the final top level TestBench file. You need to include all the files that you have created till this point into the beginning of this TestBench file, and before that you need to import the UVM package, which will give you the flexibility of using the UVM classes into these files, and finally your final TestBench module. Now you will see the last TestBench module. So this is a local signal declaration, and also you're declaring the interface handles or the interface instances. So these are the original definition of the interfaces. So you can see that in the separate interface is defined for AXI write address, write data, and write response channels, and also for read address and read data channel, and finally for the OCP interface. So this interface signal definition and their width and their individual components are specific to the AXI and OCP protocol definition. So we are creating the instance of the interfaces here. So two set of instances are created per interface, as we are having two AXI masters, and only one instance of the OCP interface is created. Next is the DUT instantiation. The DUT is named as interconnect, and it is named instantiated with the name interconnect1. So you can see that this is a DUT file. The module name is interconnect. It is having two clock and reset inputs, and after that all the ports are interfaces. So in the TestBench module, the same name is used to instantiate interfaces, thus just a dot star is enough to instantiate the interconnect. Even if your actual DUT module is not created with interfaces, you have to create interfaces in your TestBench module, and you need to pass, drive or connect these interface signals with the appropriate DUT signals. Then you will list the initial begin blocks for clock and reset generation, and in another initial begin you will instantiate all the UVM specific components. So we will look into them in detail. So in this top level TestBench module, you have already created interfaces. Now you need to pass these interfaces into the classes, and this is possible through the UVM config DB. In this specific example, I am passing the OCP interface directly into the config DB with the type virtual OCP interface, and its name is OCP interface handle, so that you can get this handle of the OCP interface in this top level TestBench module in the OCP driver using the config DB with this particular name. And for the AXI interfaces, as there are many interfaces for the single DUT, we have already discussed how to create a wrapper for all these interfaces, and it is called as AXI config, which we have already created in the session where we have discussed the AXI agent. Now we are creating two instances of AXI config, and you are filling this AXI config dot individual interfaces from the interface handles in the top level TestBench module. Thus, if you are putting these two AXI config object into the config DB, your AXI driver can get this config DB object with the name AXI config 1 and AXI config 2, and it can connect its own interface handles to the actual interface handle in the top level TestBench module. Now in the same way, if you want to set some other configuration information like whether an agent is active or how many transactions should be sent from a particular agent or particular sequence, all those configuration objects you can set in the config DB in the top level TestBench module. And after finishing all the configurations, you will be calling the run test task, which is a UVM task. So you should call this run test task with an argument which will be equal to the class name or which is a test class which you want to run in this particular simulation. So we had seen that this test is named as AXI basic test, which is an extension of the UVM test, and you want to run this AXI basic test in the top level test bench module. So you can run it by using run test and with argument which is equal to the string name of the AXI test class. And also note that you are never directly instantiating the test class in any part of your program module. So you will be passing the test name or the test class name to the run test function, run test task as an argument, and within this run task internally this test base class object is created using factory. You will never directly create any test instance in your top level test bench module. And there are two ways. Either you can call the run task with an argument, or you can even call the run task without any arguments. So if this is the case, you have to specify the name of the test which you want to run here by using a runtime argument. So this is a runtime argument. You have to use the runtime argument plus UVM test name equal to the test name which you want to run in the simulation. So here either you can directly call run test with an argument of AXI based test, or it can pass a runtime argument to your simulation like plus UVM test name equal to AXI based test. It is recommended to use the run test without any argument and specify the test name in the runtime runsim option. Now we will start the simulation of the whole environment, and you will see some simulation messages in the log file. This is compiling and running the simulation, and if simulation is ended, you are getting a waveform also. I'm not going through the waveform part as we are only focusing on the test bench part, but you can just see whether you are actually getting some information into the interfaces. So the interfaces are driving. If you see, there are 5 transactions coming into the AXI write interface 1. And if you see the simulation log, these are the UVM messages printed, and after which I am going to show the hierarchy of the classes created in UVM. So this is the first UVM information running test, which is saying the test is being started, and as we are adding a statement called this.print in the test class, this message which is saying the hierarchy of class is printed. So this is a hierarchy of classes created. The topmost class in any UVM test environment is UVM test top, and it here it is typed as the AXI based test as we are passing a runtime argument. And within the test top you have an interconnect env which is a type interconnect env type, and within the interconnect env handle there is an AXI master 1 and AXI driver 1 and AXI monitor 1 and AXI master sequencer 1. And again there are sub functions and sub UVM components like analysis, fault analysis, FIFO, etc. are there. So this is the whole UVM hierarchy which is printed in the simulation log. So I will take a snapshot and attach to this session. And after that you can see that you are getting this UVM debug messages. So you can see raising objection and starting the sequence from the test. This is a message we have added to the test class. So this is the first message we are getting. From here the objects are being constructed from top down, and the run phases functions will be starting from the bottom up. And the first message is like from the driver and the sequencer. You can see that this message we are printing in the driver and the sequencer. We are sending this particular transaction with information like read write is equal to write, address is equal to so and so on. And also you can see some messages saying the comparison is successful in the scoreboard, as we are getting the transaction sent through the AXI master 1 at the OSIP interface. And UVM also gives you a summary of the reports generated. It will say how many info reports are generated, how many warnings are generated, how many errors are generated, and so on. With this, we have completed writing a complete UVM test bench from scratch. We have developed the individual components and we connect them together, and also we have done the simulation and see how the environment is looking like. I will not add the code that we had discussed here into the session, but I will try to add a snapshot of all the classes that we have defined. The reason is I want you to practice by writing your own codes, or in the same example, you can start practicing in your own simulator. And only by practice you'll be able to understand more how these components are connected together and what is the way in which you want to start a UVM test bench environment development.